Yeah. Good evening, children. Good evening. Good evening, online students.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening, children. Okay. So continuing with trigonometry and proving trigonometric identities, this is the next one. Write on this. Continue with the number, or you can start from 1. Serial number, you can continue with the from where you start, or you can start with 1 again. The heading is prove the following trigonometric identities. Okay. So, as always, we take up the LHS. Now, the LHS, you can see that the ratios are already in sine and cos. The rule is if we have other ratios, we change them to sine or cos. If you have other ratios, then you can change them to sine or cos. But you see here, the LHS is made of only sine and cos. So we cannot do that, meaning that rule does not hold good here because it's already in sine and cos. So all the ratios look very simple, no, like 1 plus sine theta by cos theta plus cos theta by 1 plus sine theta. So deal with it algebraically, taking up the common denominator. Because there's nothing common, you cannot take out anything common. There is no other ratio to be written in terms of sine or cos. So algebraically, how would you do it? Take up the common denominator. So the common denominator is cos theta into 1 plus sine theta. All right. So now this is cos theta, but it should become cos theta into 1 plus sine theta. The denominator is here cos theta, but we want to have this denominator cos theta into 1 plus sine theta. So you need to multiply this with 1 plus sine theta, right? That means multiply the numerator with 1 plus sine theta. So that becomes 1 plus sine theta into 1 plus sine theta, or 1 plus sine theta the whole square. Plus the denominator here is 1 plus sine theta. So you need to multiply by cos theta. So do that in the numerator, cos theta into cos theta. Cos theta into cos theta. Next step. So this becomes 1 plus sine theta. 1 plus sine theta the whole square plus what is cos theta into cos theta? Cos square theta. Cos theta the whole square. Cos theta the whole square, which is written like this and read as cos square theta. It is written like this. It's written like this, and this is read as cos square theta, which is nothing but cos theta into cos theta divided by cos theta into 1 plus sine theta. Now, what do you think you can do in the numerator, children? Whatever is your intuition, tell me. What do you think you can do? You need to keep working, right? You need to do something in the next step, meaning some change in the next step. So what can be done? Sorry? Okay. One plus louder, 1 plus. Now, where is it? 1 plus sine theta, the whole square plus cos square theta. Don't you think you'll have to expand 1 plus sine theta, the whole square? So you can expand that. Like it's like a plus b, the whole square. So expand that. What do you get? A square plus 2ab plus b square. You have something which looks like a plus b, the whole square. So expand it. A square plus 2 into a into b. 2 into a into b. So 2 sine theta. 2 sine theta. plus b square. B square is plus sine theta, the whole square, which is nothing but sine square theta. Sine square theta. That cos square theta, you can write it as it is. The cos square theta there, as it is, divided by cos theta into 1 plus sine theta. Correct? Now, we know that sine square theta plus cos square theta is 1. Sine square theta plus cos square theta is 1. So next step we have 1 plus 2 sine theta plus 1. Why? Because sine square theta plus cos square theta is 1. So 1 plus 2 sine theta plus 1 divided by cos theta into 1 plus sine theta. Cos theta into 1 plus sine theta. So what can you do in the numerator? 1 plus 1, 2. 1 plus 1, 2. So 2 plus 2 sine theta divided by cos theta into 1 plus sine theta. Now tell me what can be done in the numerator? No, that you're saying denominator. Numerator. Okay, what to multiply in the numerator? It is 2 plus 2 sine theta. What will you multiply? Huh? No, you should not.
Taking out the common.
Correct. 2 is common. Taking out the common factor 2. 2 is common in the numerator. That's one of the rules, right? Whenever there's something common, take out the common factor. So 2 is common, take it out. So 1 plus sine theta divided by cos theta into 1 plus sine theta. Next one. The expression 1 plus sine theta and 1 plus sine theta gets cancelled. So what do we have? 2 by cos theta. We have 2 by cos theta. What do you understand by 2 by cos theta? That's nothing but 2 into 1 by cos theta, correct? 2 by cos theta means like a by b means a into 1 by b. A by b is also a into 1 by b. So it is 2 into 1 by cos theta. And what is 1 by cos theta? Secant theta. 1 by cos theta is equal to secant theta. So 2 secant theta meaning 2 into secant theta. 2 into secant theta is equal to the RHS. Hence proof. Right on, children? And answering your question, Naranjan, you should, in the denominator, see if you open the bracket, you cannot cancel like this. You must wait till the end. If nothing is possible, then you should open the bracket. Always in the denominator. See, okay, in this case, you'll get used to. You should just, because cos theta into 1 plus sine theta, if you open it also, it's not going to help you. How will it look? It will be cos theta plus cos theta sine theta. Even if you open it, it will be cos theta plus cos theta sine theta. That's not going to help you. What will you do with that? So don't do that. Maybe if nothing is possible towards end, you can do. Now don't do it. Yeah, right. Don't. You come by yourself or your parents drop you? Okay. Right on, children. Done, children? All of you? Online students, finish writing?
Just a minute.
Yeah. Oh, Ritika finished? Okay. Yes, children, this is the next one. So, somebody's mic is enabled. Please disable your mic. Take up the LHS. All right. Tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta. All right. Okay. Now, the rule is when we have other ratios, convert them to sine or cos. But here, since we can do it in two ways. Here, since tan and cot are reciprocal ratios, you can also work this by changing, by having tan as it is and writing cot as 1 by tan, or by having cot theta as it is and writing tan theta as 1 by cot theta, or change everything to write tan theta as sine by cos and cot theta as cos by sine. So three options we have. All the three you will get the results in the same amount of time. So we have the two ratios tan theta and cot theta here. According to our rule, other ratios must be converted to sine or cos. We can do that. But here in this situation, since we have two ratios which are reciprocals of one another, we have some more options. You could retain tan theta and write cot theta as 1 by tan theta. Or you could retain cot theta and write tan theta as 1 by cot theta. Okay. So now I'll work it using sine cos. Now tan theta. Tan theta is what? Sine theta divided by cos theta divided by 1 minus cos theta by sine theta plus cos theta by sine theta divided by 1 minus sine theta by cos theta. Once you do this, then after this, you don't have to think. What will you do in the numerator? Nothing can be done. Sine theta by cos theta. Don't again put it back as tan theta. So then what can you do with sine theta by cos theta? Nothing. Write it as it is then. Nothing can be done in the numerator. It's very simple. No, sine theta by cos theta. What can you do with that? So write it as it is. In the denominator, take up the common denominator. So sine theta is common, right? Sine theta is a common denominator, I mean. So what do you get in the numerator? Sine theta minus cos theta. Yeah. Wait, what's difficult in this? Yeah, cos theta only. But your friends are like, what happened? Why everybody's awestruck? Sine theta is a common denominator. So sine theta minus cos theta, right? What's the problem? Cos theta. Yes or no? 1 minus cos theta by sine theta. The common denominator is sine theta. Okay, so here it is 1. But you need to get sine theta. So multiply by sine theta. So multiply here also by sine theta. Here you already have sine theta. So you should multiply by 1. So it is sine theta minus cos theta by sine theta plus This one as it is, cos theta by sin theta as it is, divided by cos theta minus sin theta divided by cos theta. This is how it looks after taking up the common denominator. Now this is equal to sin theta by cos theta. I'll just give you one extra step, okay? No, I'll not write that directly. 1 minute. This is sin theta by cos theta. Let me write it like this. Divided by, this is what you have, right? Sin theta minus cos theta, correct? By, okay, plus cos theta by sin theta divided by cos theta minus sin theta by cos theta. Now division becomes multiplication. So sin theta by cos theta into sin theta by sin theta minus cos theta plus cos theta by sin theta. Very good. Cos theta minus sin theta. Very good. Next what? Multiply the numerators. Sin theta into sin theta, sin square theta. No, don't multiply. Cos theta into sin theta minus cos theta. Denominator don't multiply now. If needed, we'll open the bracket later. Because the reason is, even if you multiply, what will you have? You'll have cos theta, sin theta minus cos square theta. Again, you'll feel there's something common, bring out the common factor. Never multiply. We'll see if nothing can be done towards end, we'll do it. Cos theta divided by cos square theta. Yeah, cos square theta by theta into cos theta. Yeah, into. Now I want you to do something else here. Now see here. Okay, this one, no, look at this one here. We have sin theta minus cos theta. And what do we have here? Cos theta minus sin theta. Cos theta minus sin theta. So we'll write this one as sin theta minus cos theta and take a minus common here. I'll tell you one minute. Here, before sin theta, I should put that minus. Before sin theta. I'll tell you what it is. See here. Now, supposing you have b minus a. Okay, you have b minus a. You don't like it. You want to write it as a minus b. You don't want it to look like b minus a. You want it to look like a minus b. So what should you do? B minus a can be written as minus of a minus b. Because multiply minus into a, minus into minus plus b. So if you have a minus b, if you want, you can write it as minus of b minus a. If you have b minus a, you can write it as minus of a minus b. Both are the same. But if you have a plus b, you can simply write it as b plus a. For that, you don't have to take a minus outside. A plus b is b plus a. A plus b is b plus a. A minus b is not b minus a. A minus b is take a minus outside, minus of b minus a. Correct? Tell me, what is b? How do you write b minus a as a minus b? B minus a is equal to minus of a minus b. And a minus b is equal to minus of b minus a. But what is a plus b? It's b plus a. Yeah. All right. So that's what we do here. This cos theta minus sin theta, no? We write it as sin theta minus cos theta. Then we take a minus outside. If you put the minus sign here, the meaning will change. You can't put the minus here. Then it becomes sin theta minus. It will become a difference. It's a product here. If you put a minus here, it will become a difference. That's why we put that minus outside here. And let me tell you, see, like this, okay, so 2 into minus 3 like this, if you have like this, you cannot open the bracket and write 2 minus 3 like this, right? It's not like this. That's what will happen. If you put the minus here, it will become a difference. It's a product, it will become a difference. So you should not put the minus here. Put it here. Okay. So next step. Yeah, now let's plus into minus, minus. Correct? Now what's the common denominator? Nothing in this step. Just plus into minus is minus. Plus into minus is minus. That's all. Now what's the common denominator? Sine theta. That's all. Only sine theta minus cos theta. Okay, what's the LCM for this one? 1 minute. Okay, what's if you have something like this, something like x by okay, so b into a minus, oh no, 1 second, sorry, too many variables. Okay, a by x into x minus y, and whatever minus b by y into x minus y. X minus y is common, so x minus y. Then what about this x and y? X into y. That's a common denominator. X minus y is common, so we'll write it once. Then what about this x and this y? X into y into x minus y is a common denominator. Similarly here there is sine theta, there is cos theta, and there is sine theta minus cos theta common. So the common denominator is sine theta cos theta into sine theta minus cos theta. This is the common denominator. And here what is missing? Sine theta. So multiply that in the numerator. So it will become sine cubed theta. The numerator becomes sine cubed theta minus. Now here in the denominator, what is missing? The LCM is this. This is the LCM. Okay, this is the LCM. But what's missing here? Cos theta is missing. So multiply that in the numerator. Cos square theta into cos theta is cos cubed theta. Cos cubed theta. Now, online students, what is a cube minus b cube? Tanishka, a cubed minus b cube. Anybody? Okay, open question for online students. A cube minus b cube.
A minus b.
Yeah, very good. That's all.
A square minus ab plus b square.
A cube minus b cube is equal to a minus b, correct, into a square plus ab plus b square.
Plus A.
Plus ab, very good. Very good, Prajit. And Danya also, very good. It's plus ab plus b square. So what is a cube plus b cube then? What is a cube plus b cube? A plus b into a square minus ab plus b square. Yeah. So the numerator is like sine, meaning a cube minus b cube, right? So expanded. A minus b sine theta minus cos theta into a square sine square theta minus, not minus, plus ab sine theta cos theta plus cos square theta. Because what is a? A is sine theta, correct? Because a cubed is sine cubed theta. A cubed is sine cubed theta. So a is sine theta and b is cos theta. B is cos theta. No, Madhumita is not able to focus today. Yes. Why? Sorry? You are. You're distracted. You don't look your usual. I can make of that. Okay. Some other exam at school tomorrow? Okay. So into, okay, you continue, Madhumita. So tell me what I should write. No, first I'll write it. Yeah, then cancel it out. Huh? Okay. So this one as an expression gets cancelled. Yeah. Then in the numerator, read what you see there. Sine square theta plus cos square theta. Identity can be used. Yeah, because online students, tell me how can we simplify the numerator?
Ma'am, sin square theta plus cos square theta is equal to 1, ma'am.
Very good, very good. So, so the numerator is now 1
Plus sin square theta, sin theta plus cos theta.
1 plus sin theta cos theta. 1 plus sin theta cos theta divided by sin theta cos theta. Now look at the RHS. We need to get two terms, secant theta, cosecant theta plus 1. We need to get two terms, secant theta, cosecant theta and 1, two terms. So we need to get two terms, okay? So what we'll do, 1 divided by sin theta cos theta. We need to split this because we need to get two terms. Well, the RHS has two terms. So we'll break this and write it like this, sin theta cos theta by sin theta cos theta. That is C. When you have A plus B by C, you can write it as A by C plus B by C. A plus B by C is A by C plus B by C. So sin theta cos theta, 1 by sin theta cos theta plus sin theta cos theta by sin theta cos theta. So this becomes 1. Now this is 1 by sin theta into 1 by cos theta, because what is 1 by AB? 1 by AB is 1 by A into 1 by B. 1 by AB is 1 by A into 1 by B. So 1 by sin theta into 1 by cos theta plus 1. Because there's nothing there. So 1 it is. Don't ignore it. Plus 1. Plus 1. Now what is 1 by sin theta? Cosecant theta. Cosecant theta. And what is 1 by cos theta? Secant theta. Plus 1, which is the RHS. All right? Right on, children? Sit. Done, children? Is this over, children? Online students?
Yes, ma'am.
Yes, ma'am.
Okay, sorry, yeah. Yes, Ritika. So the other day, the recording you watched, you also completed your classwork. Any questions from there? Done, children? Online? Finish writing?
Yes, ma'am.
Okay. Here, children? Finished, all of you? Okay, so the alternate method, can I just read from the slide? Sorry? Sorry? 1 second. What? Oh, sure. You're scared, actually. Yeah, sure. Yeah. Okay. So I told you that you can also convert it to. You can also convert. Since we have reciprocal ratios tan and cot here, we are talking about the same identity, the alternate method. Okay. So I said you can retain tan theta and write cot theta as 1 by tan theta. So let's see that. Or you can retain cot theta and write tan theta as 1 by cot theta. So anyways, okay, so now see this one. So the numerator was tan theta. What is the LHS, children? LHS, this one only, tan theta. Okay. Yeah, so this is the LHS. The LHS is actually, the LHS is tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta, right? This one. So see, so you fix first what you want to change, cot theta. So write tan theta as it is. So tan theta by 1 minus 1 by tan theta plus 1 by tan theta by 1 minus tan theta. Is this correct? Everywhere cot is written as 1 by tan. Okay. So can you see that we can take the common denominator for this one? Only for this one you can take the common denominator. Correct? So that's what I've done. I've written this tan theta as it is. Tan theta as it is, and here common denominator. So tan theta minus 1 by tan theta. Tan theta minus 1 by tan theta, correct? Plus this one as it is, 1 by tan theta by 1 minus tan theta. All right. Now, just to make it more clear and easy to proceed further, I have just written it like this. See, tan, this is the numerator, children. It's very important to identify the numerator and the denominator. See here. Don't read the slide ahead. We'll go together. See, this is the numerator. This one is the denominator. Yes or no? Because 1 minus cot theta becomes 1 minus 1 by tan theta. So this is the denominator fully. Here, this is the numerator. Because cot theta is 1 by tan theta. So that's a numerator. And this one is the denominator. Okay, so see here, I've written the numerator tan theta here. So this is the numerator. This one is the numerator. This full thing, this is the denominator. And here, this is the numerator. And this is the denominator. So see the numerator tan theta divided by tan theta minus 1 by tan theta. Plus, this is the numerator. So 1 by tan theta divided by 1 minus tan theta. Now in the next step, division becomes multiplication and reciprocal. So you can see the reciprocal of this one. You can see this one reciprocal here and this one also reciprocal here. Into and 1 minus tan theta is 1 by 1 minus tan theta. Correct? In the next step, tan theta into tan theta is tan square theta. And this one, tan theta minus 1 as it is. And here, 1 into 1 is 1. And tan theta into 1 minus tan theta is tan theta into 1 minus tan theta. Now again, you can see tan theta minus 1, 1 minus tan theta. A minus B, B minus A. So write this one as tan theta minus 1 and take a minus outside. Okay. So write this one as tan theta minus 1 and take a minus outside. And in the next step, what will happen? Minus into plus is minus. So you can write it directly also like this. You can also write it directly like this. In the next step, you can change this plus to minus and write this 1 minus tan theta as tan theta minus 1. Okay. So that's the next step. So we are here now. Now after this common denominator, tan theta into tan theta minus 1. Tan theta into tan theta minus 1 is a common denominator. So what is missing in this denominator? Tan theta is missing. So multiply by tan theta. So it becomes tan cubed theta minus, here we have everything. Tan theta into tan theta minus 1, tan theta into tan theta minus 1. So minus 1 as it is. This is just common denominator, children. I'm not teaching anything new here. You already know this. Now again, the numerator is in the form a cubed minus b cubed because 1 is 1 cubed. So a minus b, a square plus ab, tan theta into 1. ab is tan theta into 1, tan theta, plus b square, 1 square. Now this tan theta minus 1 and tan theta minus 1 gets cancelled. Okay, and here tan square theta plus 1. 1 plus tan square theta is secant square theta. 1 plus tan square theta, secant square theta, and this plus tan theta by tan theta, by tan theta. Now, as we know that the RHS has 2 terms, but here there's only one expression like this. We want 2 terms. So we separate it. So we take the denominator separately for the 2 terms in the numerator. We write this one as secant square theta by tan theta and tan theta by tan theta. Secant square theta by tan theta plus tan theta by tan theta. So this one becomes 1, tan theta by tan theta. This is 1. And here you have secant square theta by tan theta. So again, to make it more clear, secant square theta divided by tan theta plus 1. This is understood. Now what is secant square theta? 1 by cos square theta. And what is tan theta? Sin theta by cos theta. And 1 by cos square theta. In this division becomes multiplication. And cos theta by sin theta. So cos and cos square theta. So this 1 cos theta plus 1. So this is nothing but 1 by cos theta into 1 by sin theta plus 1. 1 by cos theta is secant theta. And 1 by sin theta is cosecant theta plus 1, which is the RHS. All right. Write down, children. I think. Write down. This is the alternate method. Please write on this, all of you. Start like this, children. LHS is tan theta divided by 1 minus cot theta plus cot theta divided by 1 minus tan theta. This is the LHS. Done? Yeah.
Completed now.
Yeah. Okay, so this is the next one. 1 plus secant theta by secant theta. We just finished this, children. We did this one in two methods. Tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta is equal to secant theta, cosecant theta plus 1. We did this in two ways. You can try one more method. What is that? Changing tan to 1 by cot and having cot as it is. Similar procedure it will be. You will not have any trouble. It will just be like this. Like this one. Okay, you can try that. This is the next one. 1 plus secant theta by secant theta is equal to sine square theta by 1 minus cos theta. Sometimes, you can see the LHS and RHS, both of them are like, not that the LHS is very lengthy and the RHS is small. You understand what I mean? It's not that we have a lengthy expression in the left-hand side and the right-hand side is a simplified one. Here, both are like, you can either take up the LHS and work the RHS, meaning arrive at the RHS, or you can even take the RHS and get the LHS. You can do it either ways. Sometimes you may have to take the LHS, work it, you'll get some answer. Take the RHS, work it, get the same answer. So that depends. Only when you start working, you can make out what's going to happen. Okay. So we'll start with the LHS. 1 plus secant theta divided by secant theta. So what next, children? Ratios must be converted to sine or cos. So 1 plus 1 by sine. Oh, sorry, yeah. So secant theta is 1 by cos theta. Divided by 1 by cos theta. Next what? In the numerator, cos theta is a common denominator in the numerator. So you will get cos theta plus 1. Okay, this is the numerator divided by 1 by cos theta, correct? Correct. So this becomes cos theta plus 1 by cos theta into cos theta by 1. You can just leave that. So cancels and this is equal to cos theta plus 1. Cos theta plus 1, or it's nothing but 1 plus cos theta. 1 plus cos theta. Now you can even continue from here and get the, listen to me carefully, you can stop here. See, you can do two things here. You can either stop here because you feel 1 plus cos theta, what can I do beyond this? And you can stop here, take up the RHS and get the same result, 1 plus cos theta. LHS is equal to RHS. Or you can proceed with this also. So how to proceed? Look at the denominator. Sorry. Look at the denominator in the RHS. Look at the denominator in the RHS. What is the denominator? 1 minus cos theta. So what we'll do, we'll write this and multiply and divide by 1 minus cos theta. 1 minus cos theta. See, in the right hand side, the denominator is 1 minus cos theta. So we're trying to take some clue from that, that's all. Because we have to get the RHS, right? We have to work and get the RHS. We are working the LHS and we have to arrive at the RHS. What is the RHS? Sine square theta by 1 minus cos theta. So it has 1 minus cos theta in the denominator. So what we'll do, we'll multiply and divide by 1 minus cos theta. So now 1 plus cos theta into 1 minus cos theta is 1 minus cos theta the whole square or cos square theta. Correct? Because it's like A plus B into A minus B. A square minus B square. 1 square, 1 minus B square. Cos theta the whole square. Cos square theta. Okay, divided by 1 minus cos theta. Now don't disturb the denominator because we already got it. Now the numerator is actually in the RHS. In the RHS, the numerator is sine square theta. The denominator is 1 minus cos theta. We got the denominator. RHS denominator we got. Numerator we haven't got. What is 1 minus cos square theta? Sine square theta. Because sine square theta plus cos square theta is 1. Sin square theta plus cos square theta is 1. So 1 minus cos square theta, sin square theta. So sin square theta divided by 1 minus cos theta, which is the RHS. All right. So even if it is as simple as 1 plus cos theta, even if it is as simple as 1 plus cos theta, you can proceed by taking help from the RHS. RHS will tell you. When you look at the RHS, the denominator is 1 minus cos theta. So we thought, okay, we'll multiply and divide by 1 minus cos theta. All right. Yeah, take this on till. Please, Bhatt, if you have any questions, you can ask me. Done, children? Yeah. Yeah. Now, a similar question, a similar identity we had proved earlier. I told you when the left-hand side is made up of sin theta, cos theta, and 1. When the left-hand side is, okay, not left, need not be left-hand side. If one side of the identity, maybe the LHS or the RHS, but mostly it is in the LHS, is made up of cos theta, sin theta, and 1. Then, yeah, then you need to divide the numerator and the denominator. either by sine theta or by cos theta. Now, by which one to divide, you should take help from the RHS. The RHS has the ratios cosecant and cot. So let's now divide the numerator. Just do it in your mind. Okay, so you can just do it in your mind. You don't have to work. See, let's divide by sine. Okay, let's divide by sine. Let's divide by sine. Sine A, divide by sine A. Okay, what is 1 by sine A? Cosecant A. See, you're getting it. If you get one, you will get the other. Then what is cos A by sine A? Cot A. So you should divide by sine. You try by cos. You try to divide by cos. Try to divide by cos. 1 by cos is what? Secant. And sine by cos is tan. Okay. So we need to divide the numerator and denominator by sine theta. Sine A. Sine A. When do we do this? We see that the LHS is made up of sine A, cos A, and 1. So we need to divide the numerator and denominator by either sine A or cos A. But only when you divide by sine A, you're getting 1 by sine A cosecant A and cos A by sine A is cot A. So you should divide by sine A. All right? Yeah. I've already explained this, so I'm not doing it again. Please work it. And children? Okay. Okay. Online students, finish writing?
Yes,
Yes,
ma'am.
ma'am.
Okay. Let's do it once more together. That first step will not show. So we know that we have to divide by sine, right? So what is cos by sine? Cot A minus sine by sine A by sine A 1 plus 1 by sine A cosecant A divided by cos. You should divide both the numerator and the denominator by the same ratio. So cos A by sine A cot A plus sine A by sine A 1 minus 1 by sine A cosecant A. All right. So this is the first step. Now just rearrange. Take the one. Write the one here like this. And arrange the terms like as they will appear in the identity. Okay, so I'm writing cosecant A first, and then cot A, and then that minus 1. Take the 1 to the end always. Take that 1 to the end. And like we have the identity like this, right? Cosecant square A minus cot square A is equal to 1, right? So here we have cosecant first and then cot. So I'm just arranging it like that. Cosecant A plus cot A. Okay, so I'm writing cosecant first and then cot A minus 1. Denominator actually you arrange, you don't arrange, it's okay. If you can have it as it is also. It's important to arrange in the numerator. Even if you don't arrange, it's fine, but just for the sake of, it's meaning it look clear. Even if you don't arrange, you can manage. Wherever there is 1, you can just replace that with cosecant square A minus cot square A. What is the next step actually? In the numerator, there is 1. And that 1 should be replaced with an appropriate identity. And the identity here is cosecant square A minus cot square A is 1. Since we have those ratios here, we have to take away the 1 from the numerator and write cosecant square A minus cot square A. You don't meaning rearrange the term. That's also fine. But just for clarity. So we write cosecant A first, then cot A, and then minus 1 in the end. Denominator, it's okay if you don't arrange also. So I'll just write it like cot A minus cosecant A plus 1. Denominator, I said it's okay if you don't arrange also, right? So don't ask me why did you not put cosecant first. I didn't put cosecant first here in the denominator because it's minus cosecant A. I don't want to show up a negative term in the first. Okay. So now in the numerator, cosecant A plus cot A minus, what is 1? Cosecant square A. Cosecant square A minus cot square A. By the denominator as it is. So I'll just write dr for denominator as it is equal to cosecant A plus cot A minus cosecant A plus cot A into cosecant A minus cot A divided by denominator as it is. Now, what's common? What is common? Which expression is common? See, this is cosecant A plus cot A. This is also cosecant A plus cot A. This is cosecant A minus cot A. So this is like x minus x, y, x into y. X minus x into y. It's like the numerator is like x minus x into y. What is x? What is x? Cosecant A plus cot A. Okay, and y is cosecant A minus cot A. So how will you take out x common, and then 1 minus y, right? In the same way, x is nothing but cosecant A plus cot A into 1 minus y. What is y? But remember, there's a minus here. So put that in the bracket. Cosecant A minus cot A in the bracket. That's very important. Because there's a minus here. And see, after the minus sign, if you're going to write more than one term. Yes, Ritika? No, I actually I didn't get you. Yeah, tell me. X. Yeah, cosecant A plus cot A. Here, 1 instead of 1. No, I have not opened the bracket. No, see here, this is X, no? That's the next step you're where? Here, see here. Why do you feel so? See, I'm explaining that. See, after a minus sign, if you're writing one term, don't use a bracket. After the minus sign, if you're writing more than one term, then you should enclose those terms in a bracket because the minus is applicable to every term after it. There's a minus sign. And after that, you're going to, if you write only one term, it's okay. You don't have to put a bracket. But after the minus sign, if you're writing more than one term, that minus is applicable to every term, right? Then if you don't put a bracket, you will make a mistake there. So you should enclose. So when to use a bracket? After the minus sign, if we are writing more than one term, you should enclose those terms in a bracket. So see here, cosecant A plus cot A is common. Into 1, there's a minus here. 1 minus. You should write this cosecant A minus cot A. How can you write cosecant A minus cot A? Two terms are there. So put it in a bracket. Divided by. Now in the numerator again, cosecant A plus cot A into 1 minus cosecant A plus cot A. Now we open the bracket. 1 minus cosecant A plus cot A. Now we open the bracket. Otherwise, in this step itself, you should work this correctly. You must multiply that minus sign with both the terms and write it correctly. Divided by, what's the denominator? Cot A minus denominator, cot A minus cosecant A plus 1. So you can see here, you can see plus 1 minus cosecant A minus cosecant A plus cot A. Same expression cancels. Same expression. Terms are in different order, but it's the same thing. So that is equal to cosecant A plus cot A, which is the RHS. Got it, children? If supposing there was a plus here, then you don't put a bracket. Anyways, it's not, even if you put a bracket, once you remove the bracket, also same terms you will get. When there's a minus, you should use a bracket. This is exactly what you worked here, children. So here, what should you do? In the numerator, arrange the terms, write 1 in the end, in the numerator. In the denominator, write it as it is. You don't have to arrange. If you want to arrange, otherwise don't arrange. And you're not going to disturb the denominator also. Only in the numerator, 1 is replaced with cosecant square A minus cot square A. Denominator, no change. Online students, any questions?
No, ma'am.
No, ma'am.
Right. I'll let you know. Very good. Yeah. This is the next one. Ready for this, children? Today also you had biryani at home? Okay. All right. LHS. What's the so this is what you see in the left-hand side, children. Now there's a square root symbol. In the left-hand side, there is a square root symbol. But on the right-hand side, no square root symbol. So it's very clear that we have to eliminate the square root symbol in the left-hand side. But you cannot square on both the sides here because it's not you're not working it as an equation. You're taking the left hand side alone. So you can't square it. If you're working with an equation, you can square on both the sides. So supposing you have square root of x minus 5 is equal to 4. Then you can square on both the sides. But we are taking only this one, only this square root of x minus 5. Now, how can you square this one? You're changing the value. An expression, you cannot do that. For an expression, you cannot square. For an equation, you can square on both the sides. So what we do here, under the square root, Shashank, okay, under the square root, what we do? What's the denominator? 1 minus sine alpha. 1 minus sine alpha. Okay, so we multiply and divide by 1 plus sine alpha. This is understood. So it's like multiplying by 1, no? Into 1 plus sine alpha by 1 plus sine alpha. So we have seen this in the chapter rationalization last year. Number systems, rationalizing the denominator. This is what we do, no? Something like this. We multiply and divide. Okay, so this is the start. Now there's nothing but multiplying by 1. I want few people to acknowledge this, so no? Yeah. All right. Then multiply the numerators. 1 plus sine alpha, the whole square. Divided by 1 plus sine, 1 minus sine alpha into 1 plus sine alpha. 1 square or 1 minus sine alpha, the whole square, which is nothing but sine square alpha. Now, don't expand 1 plus sine alpha, the whole square. Okay, you can expand and still get the result, but take this one. The square root symbol has to be eliminated. And under the square root, you have 1 plus sine alpha whole square. So you can free it, no? Okay, how do you get rid of the square root symbol? The expressions under the square root must be perfect squares. If the expressions under the square root is a perfect square, are perfect squares, you can get rid of the square root symbol. So what we'll do, the numerator is already a perfect square. The numerator is already a perfect square. Yes or no? Now the denominator is not a perfect square. But 1 minus sine square theta can be written as 1 minus sine square alpha can be written as online students. Online students, 1 minus sine square alpha is equal to
Cos square alpha.
Cos square alpha. Raghavi, very good. Cos square alpha. 1 minus because sine square theta plus cos square theta is 1. It's 1. So sine square theta is equal to 1 minus cos square theta. Or cos square theta is equal to 1 minus sine square theta. Interpretations. Sine square theta plus cos square theta is 1. So sine square theta is 1 minus cos square theta. Cos square theta is 1 minus sine square theta. So what do you have here? 1 minus sine square alpha. So cos square alpha. Now why are we changing? Because we want to get rid of the square root symbol, and for that it is essential to have expressions which are perfect squares. And now both of them are perfect squares. So what is square root of 1 plus sine alpha the whole square? 1 plus sine alpha. And what is square root of cos square alpha? Cos alpha. So like this, we get rid of the square root symbol by converting the expressions to perfect squares. So now, when you look at the LHS, there are when you look at the RHS, there are 2 terms. So 1 by cos alpha plus sine alpha by cos alpha. So 1 by cos alpha is secant alpha plus sine alpha by cos alpha is tan alpha, which is the RHS. All right. Right on, children. finished? All right. Finish writing, online students?
Yes, ma'am.
Yes, ma'am.
All right, very good. Yeah. These are from NCRT. Everything. I started with NCRT, actually. This is the last exercise in NCRT. I started with the examples and continuing with the exercise. You're finished in school now, trigonometry? Almost finished. You started this exercise? You're following the new syllabus, right? No, they're following the new syllabus, the rationalized syllabus. Complementary ratios were taught for you. Yes. Sin theta is equal to cos 90 minus theta. Get your class work now to the class on Saturday. Yeah, children, tell me. Use the rule. Every time rule. What are the rules? Recall the rules. Why? Because you have tan the
Can we
LHS.
put theta common?
Yeah, correct. The rule is to take, or if there's something common, take out the common factor. Correct. Was it Rakshita?
Yes, ma'am.
Very good. So what's common? Sin theta is common in the numerator. Correct. So 1 minus
Square. 2 sine square.
needs some effort. Yeah. Tell me. 1 minus 2 sine square theta. Then what's common? Yeah, cos theta. Then oh, you know it, you say. Cos theta is common, but what's the first term? 2 cos cube theta. From that, if you remove 1 cos theta, what will remain? 2 cos square theta will remain. Then minus cos theta is already common. So what should we write here? 1, that's all. Now, what is the RHS? Ranjan, what's the RHS? What is the right hand side of the identity? Tan theta. Now you've started working, na? So here you already have tan theta, right? Because sin theta by cos theta is tan theta. That means you already got sin by cos is tan, right? That means this one and this one should be removed. And how can they be removed? Only when they are equal. Only when they cancel out. That means they're equal. They look different. Like see, like 4 plus 5 and 8 plus 1. They look different, no? But they're the same actually. These two are the same. 4 plus 5 and 8 plus 1 are the same. Because the value is 9 in both the cases, but they look different. Similarly here, 1 minus 2 sine square theta and 2 cos square theta minus 1, they're the same in value, but they look different. Why do we assume so? Because sine theta by cos theta, tan theta we already got, and that's the RHS. So that means this has to be eliminated, which means they must be equal. If they're not equal, they'll remain. No, something will remain. If they are not equal, then some part of it will remain. Then how will you get tan theta? So that's how we understand. So you can sin theta by cos theta, you can write tan theta here itself, or you can continue to write sin by cos, and finally you can change it to tan. Again, that's left to you. You can, okay, 1 minute. So if you want, you can write it as tan theta like this, tan theta like this, tan theta, and into, we'll work this one. So now you can do this in 3 ways. Either method 1 is have the numerator as it is, change the denominator. In the denominator, we have cos square theta, right? Introduce sin square theta. Or have the denominator as it is, change the numerator. What do you have in the numerator? What ratio you have? Sin square theta. But in the denominator, we have cos square theta, right? So in the numerator, have the denominator as it is, and in the numerator, instead of sin square theta, write that in terms of cos square theta. That's the second thing. Or you can see that 1 there, no? Write 1 as sin square theta plus cos square theta in both the places. So it's like this, 1 minus 2 sin square. I think I'll work all the 3 ways. That will be better. 1 second. We'll do it on all the 3 ways. 1 second. Okay, so first let me do it like this. So I'm changing 1 to sin square theta plus cos square theta. Minus 2 sin square theta divided by, oh no, not a bracket here, sorry. Divided by 2 cos square theta minus sin square theta plus cos square theta. See in bracket, why? Because after the minus sign, you're writing 2 terms, sin square theta plus cos square theta. So in bracket. Numerator, simplify. Are they like ratios in the numerator? Read it, sin square theta and minus 2 sin square theta. What is a minus 2a? What is a minus 2a? No, what is a minus 2a? What is 1a minus 2a?
Minus a.
Minus a. So what is sin square theta minus 2 cos square? Sorry, what is sin square? What is sin square theta?
Yes.
Minus 2 sin square theta.
Minus sin square theta.
Minus sin square theta. Minus sin square theta. They're like ratios, like terms. So we have that's minus sin. So we'll write cos square theta first, and then minus sin square theta. Minus sin square theta divided by. So here we have 2 cos square theta minus sin square theta minus cos square theta. Okay, so tan theta into numerator is done. Okay, numerator is done. Just write it as it is by 2 cos square theta minus cos square theta. Cos square theta. Like 2a minus a cos square theta minus sin square theta. So see here, they are the same. So they get cancelled, and tan theta, which is the RHS. All right. Yeah. What's the student? All right, children. Easy, no? The other two are here. I'll just explain using this. What we did is here. This method we just finished. We finished this one. Okay, I did method 3 for you. Now say 1 and 2. Okay, so here we have taken out sine theta common, children. Can you see that? Look at the first column, sine theta, cos theta common. Okay, so here what I've done is I've not disturbed this expression. I'm writing that as it is. I've not disturbed this expression. I'm writing that as it is. So in the numerator, so here we have cos, right, in the denominator, but in the numerator we have sine. So what we do in the numerator, instead of sine square theta, we write 1 minus cos square theta. Because sine square theta plus cos square theta is 1 and sine square theta is 1 minus cos square theta. So in the numerator, write this 1 as it is, minus 2 sine square theta is minus 2 into, what is sine square theta? 1 minus cos square theta. 1 minus 2 sine square theta is 1 minus cos square theta. Denominator as it is. Now, sine theta. See, you can also write this as tan, children. See, I've been writing this. You can also change this to tan directly. You can change it to tan like I wrote here into. See here, what did I do? Like, see here, I put the into and continued like this. You do that. You do that only. Sine by cos, you change it to tan and write it like this here, tan theta into this one. Okay. So you do that change. This is also fine. I'm not saying this wrong. This is also fine. You can also change it to tan. So see the numerator. 1 minus 2 plus 2 cos square theta. 1 minus 2 plus 2 cos square theta by the denominator as it is. Now 1 minus 2 is minus 1. So 2 cos square theta minus 1. 2 cos square theta minus 1. Cancel, sine by cos is tan. Write down. Sorry? Method 1 and method 2 only. Method 3 we already did. So for you, the method 3 is method 1 because we already finished. So method 2 and 3. Finished? Done writing, online students? Yeah, I'll wait. Yes. Okay. It's calling me like this. Yeah. Sorry?
My dad said he'll come at 9 p.m.
She'll come at?
9 p.m.
It's 9:15 now. Why 9 p.m.? Oh, okay. You have to leave then? Okay, use the recording. 9:15. Okay. You sure he is waiting now? Call him. I just check. Yeah, call him. No, you call from my phone. Come here. What's his number?
93 45 15 6334 6334.
Yeah. This is the next one, children. Where do you live? Where do you live? Which class? 10th class, that is Lalita. Sorry? Okay. Near which? BNP street. Okay, fine. Sorry? Okay. அந்த
10th class ஓட பாட்டா
10th class end வரைக்கும் போகணுமா? Okay. Okay. Bye. This is the next identity. Yeah. Okay. LHS. Sin A plus cosecant A the whole square plus cos A plus secant A the whole square. All right. Okay. Now let's just we'll not again the rule is other ratios to be changed to sin cos. Here you can do that, but I'll tell you why it's okay not to change also. When you expand, what will you get? What is sin A plus cosecant A the whole square? Sin square A plus cosecant square A plus 2 sin A cosecant A. The RHS you have tan square and cot square, right? In the RHS we have tan square A and cot square A. Here you will get cosecant square A, and cosecant square A and cot square A, they are related through an identity, right? So you will see that here even if you don't change, it will still help you to get the RHS. Maybe I'll work and tell you that, I mean, I can also express myself more clearly. So now this is like A plus B the whole square. Expand it. A square, so sin square A, plus B square, cosecant square A, plus 2AB, 2 into sin A into cosecant A, plus cos square A, plus secant square A, plus 2 cos A secant A. All right, cos A secant A. Now, we'll rearrange, all right? So sin square A plus cos square A, correct? Sin square A plus cos square A, correct? Is 1. And then we'll just write this cosecant square A and secant square A as it is. Actually, we can change here itself, but I'm not. And then plus 2 sin A. This is only rearranging, children. I'm just rearranging here. Though you can change in this step, I'm not changing. I'm only rearranging. Fine. There are 6 terms because when you expand A plus B the whole square, you get 3 terms. Another A plus B the whole square, 3 terms. So 6 terms in all. So we have arranged sin square A plus cos square A. Then cosecant square A plus secant square A. And 2 sin A cosecant A, 2 cos A secant A. All right. Now, sin square A plus cos square A is 1. Now, what is cosecant square A? What is cosecant square A? When I ask you, you shouldn't think what a vague question. What is cosecant square A? Meaning, what answer is she expecting? Use the identity. Use the identity and interpret and tell me what is cosecant square A. That's what I mean.
1
When I
plus
ask you
cos
what is,
square.
yeah, 1 plus cot square A. That's what I mean. So when I ask you what is 1 plus cosecant square A, I mean use the identity. Interpret using the identity and tell me what is cosecant square A. So cosecant square A minus cot square A is 1. So what is cosecant square A? 1 plus cot square A. That's the answer I'm expecting. So this becomes 1 and we write cosecant square A as 1 plus cot square A. And why are we writing that? Because in the RHS we have cot square A. In the RHS we have cot square A. We don't have cosecant, but we have cot in the RHS. Then plus. What is secant square A? 1 plus tan square A. Secant square A is 1 plus tan square A. Plus, now here you have to change it to the other ratios. So 2 sin A into cosecant. See, cosecant square A is 1 plus cot square A. Cosecant A is not 1 plus cot A. Sorry?
1 by sin.
1 by sin A, yeah. Okay. So reciprocal ratios 1 by sin A plus 2 cos A into 1 by cos A. So sin A cancels, cos A cancels. So here we get, so you have 1, don't forget that children, 2 into 1, 2, 2 into 1, 2. So let's write everything again. So now 1 plus 1 is 3. 3 plus cot squared A plus tan square A plus 2 plus 2 plus 2 plus 2. So 4 plus 3 7. So 7 plus tan square A plus cot square A, which is the RHS. All right. So first expand, and then sine square A plus cos square A is 1. Then you have cosecant square A. Write that as 1 plus cot square A, because we have cot square A in the RHS. And then we also have secant square A. Write secant square A as 1 plus tan square A, because we have tan square A in the RHS. Then the middle terms, 2AB terms, no, you have to change it to sine cos. The middle terms, the 2AB terms, you have to change it to sine cos. So we change there, and then you can see they get cancelled. So we have 2 and 2 there. And out here we got 1 plus 1 plus 1, 3, 3 plus 4, 7. Yeah. All right. Write down, children. Done, children. Okay, we'll just do this once again. Tell me, children. LHS sine A plus cosecant A the whole square plus cos A plus secant A the whole square. Yeah, oh, next step. Yeah, so it's like a plus b the whole square, right? So a square, yeah, sine square a plus cosecant square a plus 2 sine a cosecant a plus cos square a. Oh, no, I'm not able to write with your speed. Secant a. Correct?
Yes.
No, slowly.
Plus 1 plus 1.
No, not one. So we need to rearrange next. Okay, so then sine square a plus cos square a plus cosecant square a plus secant square a plus 2. No, you're racing. Plus 2 cos a secant a. All right. Yeah. Now what is sine square a plus cos square a? 1.
Plus 1 plus cos square a.
Yeah. What is cosecant square a? 1 plus cot square a. And what is secant square a? 1 plus tan square a plus 2 into sine a into 1 by sine a. Because cosecant and sine are reciprocal ratios. So cosecant a can be replaced 1 by sine a. Plus 2 into cos a into 1 by cos a. So cos a. Okay, 1 plus 1 plus 1 is 3. 3 plus cot square a plus 2 plus 2. All right, plus 2 plus 2. So finally it is 7 plus. Okay, you don't become a teacher, huh? Students cannot write if you dictate at the speed. Yeah. All right. So it's like this, children. You must practice the same thing many times. Then when this is registered in your mind, new things will be easier for you to handle. Identities, it's not about working 100 different identities. Even if you work a few, no, you must be sure about how to start them. Then you explore with new ones. There is no avlo time enga irukku. Idu padikkiradhuke time irukadu kuandalukku illaya. You're burdened with so much of work. So you practice this. Whatever little you learn it properly. All right. This is the next one. Write down, children. Online students, this is fine, right? Any questions here?
No doubts. No.
Okay. Well, I think it's time, so we'll just take down this. We'll continue in the next class. Just take down this identity, children. We'll continue in the next class. All right. All right, online students. That's it for today's session. Thank you so much. You may leave the call. Thank you, children.
Thank you, ma'am.
No.
Thank you, children. Good night.
Thank you.
Thank you. Good night.